Yeah, good evening to all. I think my voice is audible to you. Yeah. Okay, today topic is importance of power electronics in EV vehicles. So this is a topic for our webinar, and I will go through the lecture of this topic, and I will wait for a few minutes to join us. Few people, to many people also join in the session. I will wait for 5 to up to 7. 5 minutes more. Yeah. Yeah, I hope my voice is audible to you all. And let us start with the topic of importance power electronics in electric vehicle. Yeah. So this is a topic for the webinar, and also this webinar is presented by the ISI India Private Limited. So this is a ISI AJV charging. So this is a tech company and it's a skill development for the working professional and students. So let's goes to the topic first. And so everybody knows the power electronics, and power electronics is the subject for the electrical engineers who've been studying in the BTech and diploma. And some of the people are do the MTech in the power electronics. What does mean by power electronics first? So before going to the power electronics, so first you need to teach about electronics. So electronics are circuits, which is meant by the developing like so electronic circuits which be used to operate for the lower voltages, and it will give the signals to the system, and also it will use it for the turn off the switches. Like this we will use for the electronic circuits, and we have a logic gates, and these all are coding embedded part is comes from the electronics part only. But when it comes to the power electronics, so power electronics means which is a devices, which is a switching objects which can be support for a high capability of voltage and current also. So when you come to electronics devices are only support for the smaller voltage, smaller currents, but when it comes to the power electronics, they are being support for the high voltage and high capacity. So what does it mean by power electronics? So if you comes to the give example of electronics and power electronics. So for electronics, it's like a diodes and IGBTs, diodes, and also we have a transistors. These all are electronics devices. But comes to the power electronics, we have a MOSFET. So and we have a IGBT. So which are the these are also having a switching device only. But which what is the difference from the differ from the electronics is, so this can having a capacity to hold on the manage the current of high amperes. So IGBTs and switch MOSFETs are using in EV system mostly because we have a inversion processes there. We can talk more on that in the next slides. And also power electronics is converting electrical energy in the form of any kind of energy in the as per requirement we are converting electrical energy into the another form of electrical energy. So is a form it can convert the AC form into DC form, otherwise it can be convert into DC form into AC form, any other. So it is like not conversion of only is fixed for the one, but we are using different components in the sizing. When you are manufacturing, when you are manufacturing hardware, you have a different sizing on that. So that will makes you output as a differ. And the process of involving the modifying the voltage or modifying the current or frequency, any of them we can modify. I mean, we can change the voltage, output voltage, we can change the current, or we can change the frequency of the system. So these are the system, these are the power electronics, is the main parts. So it can be control the voltage, or it can be control the current of the circuit. So which can be control the frequency. So you can know AC to AC converters is like a cyclo converter, which can be depends upon the frequency. So these are the systems which have been working on the power electronics. So these are the different introduction to the power electronics. And let us talk about in the left side, you can see the chip is there. I mean, which is working on the MOSFETs and IGBTs, and you have also having a capacitors and transformers. So these all are meant to be a directed. I mean, these all are connected in the board to make a one product which is converting as a AC. It can be act as a rectifier, or it can act as a converter, any of them. So what is the role of power electronics in EV? So we will talk about power electronics in the present, but what is the role of the power electronics in the EV segment? So first one is like power electronics is the backbone of EV vehicles. Why we I will justify that point. And also these are the power electronics as well, like enabling efficient energy conversion of, and also we have a power management is also done. So power electronics is not a win by which is not a one process. It is a different kind of process. It can be do the power conversions, like it can be act as rectifier. So what is mean by rectifier? Rectifier usually convert AC supply. I mean AC supply into DC supply. When comes to the power conversion, we have inverter circuit also there. So in the inverter, we have to convert this DC supply into AC supply, because in the some of the applications they need DC supply output. In the some appliances they need DC power output. So when you are having give a example for the rectifier, we are mobiles and laptops. These all are depends upon DC supply. So when you have been charger is connecting to the your switchboard, so the charger is to do the rectification, so converting the AC supply into DC supply. So when comes to the inverter circuit, I have given the example to you. So we have a example as like in the take an example like we have a inverter circuit in the home. So whenever your power is cut, so the battery is to deliver the DC supply, and we convert the DC supply into AC supply to power the household purposes. So these are the inverter circuit which is used in the real time applications. When you comes to the converters is also one of the part in the power electronics. So what does mean power converters is, so these are converting the same energy, same power. So either is a DC, it will convert in the DC to DC, or it can convert in the AC to AC. Same power, it can be step up the voltage or it can be step down the voltage. Any of them it can done in the circuit. And energy management. So this energy management is like we have a battery in the electric vehicle. So for we don't use the entire energy in the single time. We will the system used to calculate the how much energy required for instant of time. For instant of the time, how much energy is required. So that will propel to the controller, and that will propel to the motor. So the battery will not directly all the fed to the all the energy to the motor. It will be time at instant of time, and it is managing the energy, and it is managing the ripples and all other distortion and disturbances factors. So this will effectively utilize the energy in the battery. And regenerative braking. So one of the best thing in the electric vehicle is regenerative braking. Definitely the regenerative braking is best, because when you have been applying the brake, also we can using that energy in the system. So why? How do you using that? So when you have been braking, the kinetic energy is flowing there. So whenever kinetic energy is converting to the electric energy, is a medium is there. One medium is there. So that is a controller. Controller will act as a converting the kinetic energy to electric energy, and it will fed back to the battery, and it will charge the battery. So whenever you brake applied, so the motor, the control will be activated, and it will tell that, so this time is to not to discharge, this time is to charge the battery. So this is the motor controller. And so in the controller also there is a lot of microcontrollers. There are a lot of microcontrollers and IGBTs and power electronics are there. We will talk more on the regenerative braking slide. And I hope role of power dynamics, power electronics is delivered to you. I hope you get it. If you have any doubt in the, if you have any doubt, you can ask me in the middle of the conversation. And yeah, is my voice is audible?
Yes, sir.
Okay. Thank you. Yeah. So the first topic is our power conversion. So via this is a very basic to the electrical engineers, I know, but this is my point of view. I was covering to the both mechanical and electrical students. So they having, for electrical student they will cover the basics, and for comes to the mechanical student they will learn it. Okay. So the power conversion is like we have a three types of conversions are there. We can have a convert the AC into DC. AC into DC is the rectifiers, and DC into AC will be inverters. So and third one is the converters. In the left side we can see there is a board is there. So board having a that is a clumsy we have seen, but is alignment is there for the converting some energy, converting some form of AC into DC or some form of DC into AC. So we have a in hardware circuit we have a capacitors, we have a power electronic devices like a switches, and also we have a resistors. So what does do capacitor is? Capacitor is to store the energy whenever is excess of energy is there. Whenever is whenever is energy is stored in the steady state, it will be store the energy. And if in under process, if any one point of time the switch is closed, switch is open, so it will deliver the power. So this is the case. It will be understood in buck converters. In the buck converters, we use a capacitor. So whenever is switch is closed, in other side the power will be flowing in the closed circuit. And when comes to the capacitor will be store the energy, and resistor will be resist the power of flow. Resist the current in the resist the current or voltage in the circuit. And comes to the inductor. Inductor is used to, what is the nature of the inductor is, it will oppose the sudden change of current. So these components are very important in the designing of the hardware. So designing of hardware because of to flow of the energy within the limits. So I in this slide, what I'm explaining is inverter circuit. So and also after that we have a rectifier. After we have a DC-DC converter. These are the power conversions which is have been included in the power electronics. So next is charging. So why I'm in the charging is a different parameter. Why I'm in talking in the charging in the power electronics. So one thing you need to remember is like whenever charging is there, whenever it's charging, so charger has to connect with the battery. So there is a communication protocol is there whenever it's charging connected. So here is one thing operation is there. How much of energy is flowing from the battery to the from the charger for output? How much of charging? How much of current? How much of current is going flowing from the output of the charger to the battery? This is the most important. So this we will we will arrange the circuit. So we will have a charger. In the charger is like a we are using onboard charger, like a OFF onboard charger. So in the onboard charger, what do you do? So in the onboard charger, we have to take the DC AC supply from the charging grids. So we have a plugging the charger in the AC grid. After that, we will plug output to the battery. So here is not battery directly connected here. So battery doesn't consider the AC supply at all. So we will convert to DC supply at the middle of the conversion. So we will use onboard charger in between that. We will install the onboard charger which does the main process is it will convert this AC supply into DC supply, approximate and perfect synchronization between the battery output and charger output and battery output, and also how much current is required and also how much voltage is required to the battery at the output. So it onboard charger will be decided. So this is the thing I need to explain in the battery charging. And power electronics have been which is used in the BMS also. BMS are charging. So whenever it's charging, whenever it's overcharge is there, that is time to discharge. So if not discharge, it will be blast in the circuit. So we will use a MOSFET in between that. Whenever it charge, it fully charged is there. So we will turn on the MOSFET to discharge. If overcharge is there, if your undercharge is condition is there, if undercharge means so less than we will you use the battery up to 20% or 30% of the battery you used, only 30% is charging. So that is a state which will not go for the discharge. So the actually battery will be after decreasing of 20 degree 20 SOC 20% of SOC. So it will turn off. It will don't give the supply to the motor. So here is MOSFET will be open. So why I'm talking more and more about MOSFET and IGBTs. MOSFET and IGBTs are the switches which is capable of high voltage circuits. So if you give the gate pulse to the IGBTs or MOSFET, it will turn on, it will act as a switch. If you're not given the gate pulse to the IGBTs or MOSFET, it will open the circuit. So whenever you're in your overcharge condition, we will need to open the circuit. So we need to don't want to discharge. So whenever is overcharge is there, we need to close the circuit. Sorry, whenever is overcharge condition is there, we need to close the circuit. We need to discharge the battery power flow. When it comes to the under discharge, you need to open the circuit. So if you open the circuit, the power will not be flow to the controller. So it is the time to charge the battery. So this is the battery charging conditions. So this is the block diagram is a BMS, and in the BMS also we have a power electronic devices also there, because so in the BMS we have a battery pack. In the battery pack we have a current and voltage and temperature. Is these to monitor every time. So we have a sensors. We have a sensors to measure the current, or we have a sensor to the voltage. We have a sensor is the temperature also. So these are what to do. These has to sense the temperature. So what is the current at instant? What is the voltage at instant? How much charge is going from the or how much whenever charging? How much current is going to the battery pack? How much whenever is flowing out? How much charge is flowing out from the outside? So these will be monitored by the every point of time. This will be monitored in the BMS. And also we have a like a data acquisition. This is microcontroller is there. So we have a cells. We have a n number of cells in the battery pack. So in the battery pack, we have connected in series and parallel. So in the series and parallel, we will monitor the voltage and current and temperature. Definitely, these are the big things. After you are measuring these things, so we will give this data to microcontroller. So microcontroller having the code. So it will be exceeding or not. It will be if your voltage is exceeding somewhat voltage. If your battery pack is 48 volts. So if you're charging the battery, it will goes to 60 volts. So if you goes to 60 volts, the microcontroller has to do the job. So it will turn off the switches, it will turn off the circuit. So it will microcontroller will have a coding part. So which voltage monitor the all the components. And this microcontroller will be dependent in the like microcontroller used to determine the how much state of charge is there. So how much charge is present in the battery pack, and also it will communicate with the battery pack. It will communicate with the controller as well as, yeah, as well as it will communicate with the display. So we use the like vehicle, we use the in the EV vehicles we are using display. So display we are showing the SOH. So SOH we are showing there because how we are showing that we have a communication protocol. So this communication protocol is directly contacting with the BMS. So this much of energy is there in the present of time. So we will displaying the we are showing in the display in the EV vehicles or any EV vehicles, either two-wheeler or three-wheeler, four-wheeler. So this is a practical case, which is I mean, this a BMS is also having a safety procedure also there. If you have any over current is there, if any over voltages are there, if any over temperature, or if any these things are happening there, it will shut down the system. So these are the things which is the BMS block diagram, and these all procedure which is all depending upon the power electronics. So the power electronics plays a crucial role in the thermal management also. In the thermal management, what does it do? So it measures the temperature of the vehicle. It will provide the cooling system if any higher voltage is there. If not, it will be stable condition. So this is the thing. And regenerative braking, I already explained to you. This is converts the kinetic energy into electrical energy, and during the braking, so it will improve the charging. It will improve the battery pack capacity because it will improve the battery pack. And also you can see the block diagram here how it will be there. We have a battery pack. So in the recent time, I mean normal mode, in the driving mode, what will do, the battery will be having energy. It will go to the inverter. So inverter, what does do? Inverter is converting AC into DC, I mean DC into AC. So it will go to the motor. So motor will be, or motor output shaft will be connected to the shaft of the tires or shaft of the gearbox of any other. So whenever you motor is rotating, vehicle will be motion, the vehicle goes to the motion. So in the when you apply the brake, what happen? So this motor will be at a generator. So whenever what is the generator principle? Mechanical generator will do mechanical into electrical energy. So the motor will be at a generator here. So the inverter will be again converting into DC power into AC power into DC to the battery pack to charge the battery. So this is the mode. You can see the GIF here. I mean, this is clarity to you. So when a generative mode is there, we have a charging. Whenever a regenerative braking, whenever braking is applied, so with the battery is charging here. Whenever is driving is mode is there, the battery supplying to the supplying the power to the motor. So this is the basic thing which is using the regenerative braking. So in the regenerative braking also, the power electronics plays a crucial part because we will use to here is inverter is again converting acting as a rectifier because it will AC. It will acting as a reverse condition also. Bidirectional will be flowing here. So bidirectional is also there in the system. And we have a thermal management. So in the thermal management is also have a place of power electronics is a crucial role to the monitoring the temperature. Like you can see that in the BMS, I have told you that every cell has to measure the temperature and voltage and current. And so with these, every temperature of cell is within the optimal temperature or not. So if not optimal temperature, we will have used to do the some coding. We will turn on some MOSFETs in the system. We will do the some parameter. We need to change some parameter in the system. So that will do. So what does do? First step is we need to sense the temperature in the battery pack, and we will activate the cooling systems. After that, we have a heating elements. So heating elements means in the battery pack, heating elements is resistors and cells. So they are heating elements. They are producing heat at every point of time. So the power of the distribution will be equally distributed. If what happens, why is thermal management system is comes to the picture? If you are not balancing the cells in equal manner, so what happens? Someone is speaking. If have a doubt, you can ask me that. So here is in the cell balancing technique, what happens? So if you are not doing the cell balancing technique, if you're not doing the if your cells are not taking out the voltage and current out as a similar to all the cells. If some voltage is some first cell is taking more voltage, second cell is taking lesser voltage, what happens is there is a disturbance, there is a potential difference between two cells will be differ. So there will be a cause of heat in the system, so that will respond for rising in the temperature. So we should remember the power distribution of the system is every time is a constant and optimization. So this to me remember every point of time. In the you can see in the image side, so there will be like battery pack is there. So battery pack having a channels which is you can see the channels are connected to the motor, and you can see indication of red color. So there is like temperature is somewhat affecting there. So in the battery pack is also temperature is also crucial role. So the power electronics is the device which is controlling this temperature and measuring the temperature or distribution power in equal manner. So these are the responsible for the power electronics. So every time the power electronics is the plays a crucial role. If you study more and more on this subject, you will do the wonders in the any sort of devices, not in the EV vehicles, in hybrid vehicles also. So the key components I talk about inverters, so and also converters and battery management system, and also we have a these having converting. Why this important? So inverters are using in the EV we have a controller in between there. So in the EV vehicles we have a battery, we have a inverter circuit, we have a motor. So by changing the inverters switching, we can control the speed of the motor. So this is the most important thing, which is having a best thing in the power electronics. If you are changing the frequency of the switches, if you're changing the time with, or you can changing the duty cycle of the pulse width modulation of the gate pulses, we can changes every speed of the speed supply to the motor and voltage supply to the system. So and also converters, we have a managing the different types of voltage levels. So we will talk about more and more. So I'm here is the key components and the functions. I will talk about more on these next slides. You can see in the left side we have a battery packs. This is the battery packs, and this is the BMS, which is used to monitor all the battery cells in the system. And we have high voltage cable. So every time remember, high voltage cable will be indicated in the EV vehicles is orange color. So orange color, and we have a power electronics devices which is used to converting the power supply. I what I mentioned in the previous, everything will be do in the circuit. And the solar rope is also there. You can see in the solar what is the output. In the solar is also output is DC supply. So if you want to energize the supply to the motor, so we need to, if you want to distribute this power to the motor also, we need to convert the system. So these are the things we need to do, remember. And inverters, I already told you that inverters are the multiple types are there. So in inverters, what does do? It will convert a DC supply into a supply. We have a single phase inverters. We have a multi-phase inverters. So inverters, what does they have in the circuit? In the inverter circuit, what do we have? Four components which are important in the circuit. One is DC source, another one is control unit, another one is filters. Because we have a not, we will get a pure AC waveform. We will get a pulsating AC waveform. We will get in the output. So by using filters, we will filter it that ripples in the circuit. And we have inverter circuit. After this process, we have a get the output of AC output waveform. We will get in the output. So these are the four steps you need to remember. Every inverter circuit is having these things. Either in single phase inverter, or it will be multi-phase inverter. Any of them, this will be a constant for that. So this is the single phase inverter block diagram. You can see in the block diagram we have a four MOSFETs. We can assume as a IGBTs also. So there is a four MOSFETs as there. So we have a supplying DC supply here. So this is the gate pulse. So this gate pulse is controlled by PWM signal. So the PWM signal will control these gate pulses. So and also this is the load. So what happens here is whenever you give the supply to this, the gate, only two switches will be on in the every time. So either G1 or G2 will be on, or G3, G4 will be on. So this will be controlling the switches in the inverter circuit. We will convert the AC waveform. We will convert the DC waveform into AC waveform. So whenever you are converting the G1 and whenever you turn on the G1 and G2, so what happens is that there is a closure loop is formed. So we will supply the voltage to the DC voltage will be flow through this MOSFET. So this MOSFET will also turn on. It will be like opens close the circuit. So the voltage will be flow from this. like this, and it will go to the load, and it will return come back to the G2. So G2 to ground. So we have a positive waveform, and negative waveform will be like coming from the G3 and G4. So whenever you have been after second of point of time, G1 and G2 will be turned off, and G3 and G4 will be turned on. In that time, what will be happen? So this will be go from the G3. So in this negative waveform, what will be like? In the negative waveform, we will go for the G4, and G4 to load, and load to we have a G3, G3 to positive. This is the second waveform which is having the negative waveform. So we will convert the positive waveform and negative waveform in the load by using by turning on the switches in the circuit. So after that, you can see how the inverter works. So whenever your battery supply is given, the switches S1 and S4 will be turned on. So then we will forming the positive waveform. And whenever is S2 and S3 waveform switches will be on, we will forming the negative waveform. As the end of you consider the one positive wave cycle 360 degrees, we have a converting as a pulsating pure, not PC waveform. We are generating the pulsating AC power supply. So this is the thing. The inverter circuit will be how will be activate. So you can see in the place of load we have a assume the bulb. In the bulb we have is supplying two direction. It will be positive direction will be going on, and negative will be also going on this circuit. So the three phase inverters also same thing. We will do that. We will control the three. We have a six switches in the here. In the six switches, we divide into high voltage side, and we will divide in low voltage side. So we will turn on these either these two switches or either these two switches. You can see in the GIF also. So by these two switches, we are converting the A phase and B phase and C phase in the circuit. In the motor of a in the motor, we are converting A phase and B phase and C phase by using convert by switching the six switches in different waves. We will turn on every time. We will turn on two switches only. Remaining four switches will turn off. So at point of gate pulses, that will converting that will switching transforming into A phase or B phase or C phase, either it. So you can see IGBT switches are using here, and DC supply is there, and controlling the voltage here. You can see the controller is like controlling the gate pulses. I will told to you that we have a DC power supply, we have a IGBTs. I mean, we have a control supply, and we have a filters. At the end, we have a load. So everything is covered in the inverter circuit, and we can see the pulses in the positive waveform. We will get the this. This is not seems like a sinusoidal waveform. It will seems like a trapezoidal waveform, but we will using the filters. We will convert into the pure sine waveform. So based on this waveform of output, we will control the signal. So it will come different part. So this is about the three phase inverter. By controlling the one by two switches, we will control the A phase and B phase and C phase. So this is the thing. And we have a power electronics in EV components. So the power electronics in EV components, this is the real time diagram. This is was you can see we have a battery pack. So we have a capacitor. So the capacitor is used to store the energy, or if you want to in the close, if it will deliver the power supply. If switch is open, and you can see the battery pack is connected to the inverter circuit. So this is the inverter circuit, and inverter circuit is connected to the controller. So this controller will be connected to the gate drivers also. This gate drivers is responsible for the switching on, switching off the supply. So at the output, we are what you are getting? We are getting 12 volts to 14 volts. Actually, this is a circuit which is like buck converter or boost converter. So here is step down the voltage. We are not doing any inverting the circuit. We are step down the voltage also here doing. We have a battery voltage around 48 or 400 volts will be there at in real time example. But at the output we having like 12 volts to 14 volts. Why we are converting this is because it to supply the auxiliary items. In the vehicle we have a cars. In the cars or any vehicles we have a lights, signal lights and tail lights, and everything is there, auxiliary items. If you supply 400 volts to that auxiliary items, what will happen? They will cannot withstand the supply. They will burst out. So they will fault will be occur in the circuit. So that's why we'll step down the voltage by using same battery pack. We don't using another battery pack to do the to supply the auxiliary items. We are using same battery pack to energize the supply, to energize the system also. So this is the thing I need to explain. So the controller is responsible response for the controlling inverter or circuit also. It will converting DC sub. It will sub down the voltage also. I mean, if you know the more and more about power electronics, you will can you go for the build your own controller yourself. Control is the main brain of the electric vehicle, so which is all been connections, all protection, everything is in under in the control system controller. And this is a converter family, and in the converter family we have AC to DC. I already told you that, and DC to DC and AC to AC inverters. And in the AC to AC inverters, we will have a called as cyclo inverters, or we have like voltage regulators, AC voltage regulators. And also we have a DC to AC converters. So the DC to AC converters, I already told you that this is the inverter circuit, and DC to DC we called as a choppers. So choppers, what to mean? Choppers have in two types. We have a buck converters and boost converters and buck boost converters. So we'll talk more on next slides. And we have a buck converters is like step down the voltage. In the left side, we can see the diagram here. So this is the buck converters real time diagram and real time view. And the buck converter is used to step down the voltage. It will take the input voltage higher voltage, and it output voltage will be lesser. And this is the ideal cases, which is in the previously I told you that. So we will have a battery is a 400 voltage. We need auxiliary items having a lesser voltage required. So there we will use a buck converter. This is the circuit we will use in there, but it's not is a similar. This is not a simple that will be designed in the very more accurate and more. I mean the ratings of the MOSFETs and rating of the capacitors all are different, but the designing is same. The parts are the components which are using the hardware part is same, but rating will be different. So this is a need I need to explain from this. And buck converter is buck converter is step up the voltage. So we will have a in the real time we will need to step up the voltage. There you use the buck converters. So in the buck converters we will is a take the input for the I will give the real time examples also. We will have a in the battery pack we will supply the voltage from the battery pack to controller or motor. We will use some lines. So in the lines also there will be a drop in the voltage, so we will use a buck converters or boost converters to sub up the voltage if they required. Or if you are using air conditioner in the cars also, they will require more voltage there. So we will use a buck converters there to step up the voltage. So these are the applications. These are the real time applications I'm telling you that to how you buck converters using in the real time. And I already told you that battery management system. So we have a battery management system. We have a battery in cells in series, connected in series. Cells are connected. We have a cells, so that are connected in series and parallel. So the battery management system we will have a cell monitor technique. So we will monitor the temperature, voltage, and current, and based on that we will measure the state of charge and thermal management system and state of health and capability of how much of time it will become. It will estimate that, and it will communicate with controller. So the BMS is also hardware part, which is having a lot of our electronic device will be deals with there. So we are using lot of devices to control the device, to control the system, and also to measuring, to sensing the device. Also we are using some sort of sensors. They are also totally deals with power electronics. So these all components, which is all deals with the power electronics devices. And you can see. So these are the this is the clan. This is the battery pack inner diagram. BMS inner diagram. So in the BMS inner diagram, we have a 12 volts power management voltage regulator. So this is lot. This is the battery pack, which is we have a real we use in the cars and any other. So in the battery pack, we have a battery management system. So the battery management system is having interference to control all the methods. So it will control the power voltage, or it will control the every cell parameter, or it will communicate with other parameters. It will communicate with controller. So controller will ask the battery pack. So driver want to go with this speed. So this much of speed, this much of voltage are required this point of time. So then controller will calculate the how much voltage required at instant. So it will drag from the BMS. It will drag from the battery pack. So there is a communication between battery pack and controller is must be good, and also communication between motor and controller is also has to be established. So there will be a communication is when it comes to the ECE students also. So in the EV department there will be a lot of technologies and lot of opportunities also there, because we will use a work on the CAN protocol, or we will use the LAN protocol. Lot of protocol we will work on this, because whether the connections are the whether voltages are transferring or not, whether it is working on stability or not. In the CAN or CAN protocol or LAN protocol, OCC protocol, n number of protocols are there. We are using charging stations also. We are using in this also. So what I'm telling here is ECA students are the more opportunities are there in the EV domain, so they can work on these protocols mostly. And when it comes to the electrical engineers, they will work on the mostly on battery designing pack, designing the BMS, and designing the M controllers. When it comes to the electrical mechanical students, they will work on the designing the chassis. I mean, even in the mechanical students who have been now very enthusiastic to work on the power electronic device also. I've seen most of the people are working on the power electronic device. They are mechanical department. So there is no point to learn the power electronics. We can learn it with you, have a good guidance with you. And you can see the power electronics, we have an onboard charger. So I already told that onboard charger is to built in the car only, but onboard charger will take the input as the AC input, but it convert to the DC output. So the charging station will always be charger, either could be either DC supply or a DC supply. In the charging station, we have a DC fast charging station also there. We have a AC grid also there. So we can use any of them based on your car. I mean, based on your vehicle specifications. Onboard charger is bypass. The current is sent via BMS directly to the battery pack. So the charging has to communicate with charging have some protocol. Charging has some protocol. Charger has to communicate with BMS also. So BMS is the most important thing in the electric vehicle and battery pack also. It will monitoring the data. It will calculating the how much charging there, and it will communicating the device with all the devices, entire devices with the controller and charger, and also with the display and everything. It will communicating with that. So this is the layout diagram I'm need to explain here. So this is the onboard charger. So onboard charger we have a rectifiers and DC converter to the rectifier. What does do? I will also tell you that AC to DC. So after that we will use a DC converter to minimize the voltage, or to remove the ripples in the system. So that will charge the battery. So the battery will be convert the battery having a, so in the battery we are also doing rectifiers. So if you are being going for the onboard charger, this is the half board charger. So in the half board charger, what do you do? So we will supply a DC supply to the system. So if you know half board charger, we have a, you can see half board charger we have a DC supply is input. So the fast charger is a half board charger. They are not onboard charger, because onboard charger we need to convert the supply. We need to convert the supply. We don't have an option to the convert. We are convert the supply. We are converting the AC into DC. So there is some losses will be happening there. But when it comes to the OFF hardboard charger, we have it directly feeding to the DC supply. We don't have a process like a rectifications in the between there. So that's why we will have a offboard chargers or fast charging station, and we will have a motor. We have an inverter circuit, and this is a layout diagram which is all about power electronics, but is when you going for real time. So this is not look like, this is like small devices which is in the hardware part you can see there. But there is a small devices, they are a small device, but they are working very hard. So they will capacity, they will do the work in an efficient way. They will give the 100%. They will be very compact, and they have been, we can convert 400 voltage in simplerly. Very simple in the compact size. By using in the compact devices, we can convert 400 volts. So that is the power of power electronics. So, and what is your company? You can have a efficiency and power performance and improvement. So when it comes to the system, when it comes to the power electronics, so we have a this using, by using this we have a reducing the losses. So we can reduce the losses because the all elements can be having higher efficiency. Switching devices and everything is higher efficiency, and we can protection. We are reducing the heat in the battery pack, or by using this MOSFET, by using the power electronic devices, we are reducing the weight, and you are increasing the overall efficiency. And by how you are increasing overall efficiency by using the power electronic devices, they are very compact in size, very less in size. We are increasing the size components of the vehicle, we can increase the speed of the vehicle also. So this is the vehicle dynamics part. And also energy efficiency, we are delivering the every point of time where conversion is there. Every conversion is there here. Every point we have a DC conversion, we have AC to AC conversions. Every conversion is there, but every conversion there is a no there will be efficiency will be like 90 to 96% efficiency will be there in the every point of time. So that much of efficiency will become in the only power electronic devices, only in the electrical components, this thing. So we have a energy efficiency is also suitable this, and very less cost. I mean, compared to all these things, we are compared to bit cost only, but not bigger cost. It will be like moderate cost will be there. And if you do the more research on power electronics, if you do the more research on inverter and converter circuits, so we will get the more accurate results and the power electronic devices. And this is while using the power electronics, we can increasing the efficiency of the system. We can reducing the losses in the system also. We are reducing the heat losses in the system also. So these are the things I need to explain from the power electronics. And the power electronics which is all are required in every components, either in charger, either in controller, or either in buck boost converter to charge to supply the auxiliary items. Or you can in the onboard or offboard charger, we can use any point of time. This is very important. So this is the things my side. If you have any doubts, you can ask me that. um, yeah, I mean, if you have any doubt in regarding my session, you can ask me the questions. Or yeah, you can ask me the question. I mean, if you want any repeat in any session, any slide, I will repeat that. Yeah, I mean, nobody having any doubts. And if you,
Hello, sir.
yeah,
Sir, when you explain the topic that is the buck converter in case of the DC to DC converter, so you can say we can use a buck converter in this case for driving a electrical vehicle that is operating. I mean that is operated in a high voltage. So why we shouldn't use the boost converter? I mean that is so low. I mean that's converted lower voltage to higher voltage DC. So why we use buck converter, not boost converter?
so buck converter, what does the buck converter? Buck converter used to step on the voltage. So
Yeah,
why
yeah.
I'm saying the buck converter there? We are using auxiliary items like a signal lights. We are using headlights. So these are being working on the low voltage side. So there will be
Achha.
required 12 voltage supply. So battery is supplying is 400 volts or 48 volts for two wheeler. So if you supply directly to the auxiliary items, what will happen? There will be fire out. So that's why we are using buck converters there. Yeah.
Okay, thank you, sir.
Yeah.
So, hello.
Yeah. Yeah. I'm listening yours.
Sir, which microcontroller is mostly used for BMS system? Means which is
Uh,
highly recommended.
there will be like ARM Cortex and also STM. ARM Cortex is using more for the microcontroller for the BMS, and also there are other technologies also using now. Um, Other technologies also used, but I'm not recollecting now. Arc Cortex will be first thing which is using in the BMS.
Okay, sir. Thank you, sir.
Yeah. Yes, Vinod. Yeah. Is it correct? I mean, small correction in there is a buck converter is also known as step down converter. There will be step down, not step up converter. Yes, I mean I don't tell you that step up converter that was. So buck converter is a step down converter only. Sir, which program is used to support for coding microprocessor? So yes, we will have a C language. C language used to mostly is for the microcontroller programming. This is the base. C language is the coding for the microprocessor coding. So this is the thing. And also someone is asking good presentation. Yeah, very good, nicely. Thank you. And is there any MATLAB related orientation? So yeah, I think we have a. I mean, if you have any related the question, you can go directly ISI in your website. So we have a course on MATLAB also. MATLAB Simulink to design the circuits. For you can design whatever said in inverter and converter in real time in the MATLAB and Simulink. That is the most important. Yeah. Okay, Tarun.
Thanks for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company, ISO India products and services that we offer in EV technology with a small video. So kindly have a look on video.
As we are living in the fast changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, e-bike design challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the Economic Survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means We could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions, and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQ courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero MotoCorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Kalgotias University, Sharda Universities, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop a workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video presentation. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this course, kindly send us an inquiry through QR code displayed on your screen and take your first step towards a more sustainable and exciting futures. Thank you.
If you have any query regarding to courses, you can scan this QR code. Our executive will contact you shortly. So if you are looking courses for electric vehicle, you can scan this QR code. Our executive will guide you better which course you have to take. Thank you for joining.